Yes, please. A very good morning. Is it audible at the end? Yes. Good morning to online students too. Please switch on your cameras. Yes, write a few thoughts. This is our second lecture. This statement is good for essay writing. In the practice of tolerance, one's enemy is the best teacher. Means by being tolerant with the people at home is nothing great. You need to learn tolerance whom you otherwise hate. The second is a Chinese proverb. Teachers open the door, but you must enter by yourself. Basically, the message is that don't depend too much on classes here. See, now you are all trapped, no? You already have taken the admission. Don't misunderstand. I'm just joking. That will help you open the door quite wide open, right? So that you can easily enter if you wish. Again, good for essay writing. Let the people think they govern and they will be governed. This is what politicians do all throughout the world, and Indian politicians are very good at it. They make you feel as if people are important, and in the very process they rule us. No winter lasts forever, no spring skips its fun. It means that you have to work hard for some time, but achhe din will come, no? The next one is little philosophical, let's whether you understand or not. All sins are attempts to fill voids. We do wrong things in life because we have voids in our personality. So through good education, socialization, we should avoid having voids in the very first place. The last is nothing that is natural is disgraceful. So more you study ecology and geography, you'll get to know whatever Mother Nature has given us, it is all with a purpose. Even earthquakes, volcanism, tropical cyclones, which all appear to be so destructive, they are all with a reason for the earth to continue as a planet. So whatever is disgraceful around us, it is all addition by mankind. Nature gave us everything good. That is the learning you'll have in this subject. Now this student asked me to explain the second quote. I did it so well, no? I said, don't depend on us. Means we can take the horse to the water, but it is the horse who is to drink the water, no? That's what is the other way to understand. Fine. So let's start with our geography lecture. Please reconnect with the last lecture's last portion. We completed something about the Earth's shape. So just to have a quick recall for those students who have not seen their notes, Greeks gave us a simplified understanding that Earth is a perfect sphere. And this notion that Earth is a perfect sphere remained unchallenged for many centuries. Then came a correction to this concept of Earth being a spherical shape in 1687 by great scientist Isaac Newton. Newton very rightly said that since my Earth is spinning on its axis, so it cannot be a perfect sphere. Now, because of the spin, there is a force called centrifugal force, and that leads to misshaping of this Earth. And that misshaping is that Earth bulges through the middle portion. And today we'll see this middle portion is technically called as equator, and it is flattened at the top and bottom, means the poles. This flattened sphere, which was suggested by Isaac Newton, technically came to be called as oblate spheroid. But in the 20th century, when we saw that the Earth's surface configuration is very unique with high mountains, deep valleys and oceans, and we saw this through the satellites imageries. So giving primacy to the uniqueness of the Earth's shape, and Earth being the only known living planet, so our scientists gave a unique name to the Earth in terms of its shape. So today we call the Earth as a geoid. But at the end we concluded a very important point, that though Earth is not a perfect sphere, but its variation from the spherical shape is so less that we can practically, for most of the things we study in geography, we can ignore that variation. So the rule of the game is, unless until I say otherwise, Earth would be taken as a perfect spherical body, right? With that point we start, but wherever we need the variation, we'll mention it and use it, okay? Now, let us go back to our school days today in this lecture. You know, for a place to be located on the Earth's surface, we need an address. And you have done in school that this address on the Earth's surface, which is spherical, is comprising two angles, one called latitude and the other called longitude. And today you will see, based on latitude, we have some lines called parallels. And there are some lines based on longitude called meridians. And the network of these two sets of lines is what you see on the globe as grid system, okay? So in the next 45-50 minutes time, we'll have understanding of these four concepts and related things. Now, to create the context for this lecture, for the first 1 hour or so, let us go into history. And please don't write till I make you write, okay? Be on the board. Now see, in the coming lectures, I'll be dealing with concepts of time, what you have done as local time, standard time, etc. The story would begin from 1850s onward. By mid of 19th century, the scholars in the Western countries started realizing that time has come that we should go for some common rules for time for the whole world, because the world society is highly integrated by that time, economically and socially. So the scholars of the Western countries thought that time has come, we should have some common reference of time for the whole world. But to have the common reference of time, we need to first have some common system to locate places on the earth's surface. For example, you might remember from school days, or you'll understand in my third or fourth lecture, that for time, we need to have the concept of prime meridian if we need to have one concept of time for the whole world. Meridian is what? Today you'll understand. Meridian is a line which joins North Pole with South Pole. So if my left hand is the earth, this is North Pole and this is South Pole. So lines which join North and South Pole, they would be called as meridians. And when I say prime meridian, you can think of some major or initial or reference meridian as such. So scientists of the Western world understood or realized that to have the common reference of time, we would need common system to locate places on the earth's surface. Means we should have common concept of time based on some prime meridian, right? Only then we can talk with one frame of reference. So for all these things, the scholars of the Western countries started making efforts to impress their political leaders that go for this change. And through the efforts of some such scholars, whom we'll mention in the coming lectures, by 1884, there was a conference held in the city of Washington, D.C. And this conference, which was attended by the scholars and some leaders of the Western world, we were not that important at that time. So it was dominated by the Western world. And this conference was held in this year 1884. And the name of this conference was International Meridian Conference. In short, I'll be calling it as IMC. It would be discussed more in the coming lectures. Now, in this conference, the scholars decided most of the things which we are using today as a world society. Now, let us leave it for a minute and come back to our system to locate places on the earth's surface. At this moment, broadly, I'll say latitude is the angular distance of a place, north or south of some reference. So think of this, that latitude is what distance? North or south of some reference. Let me call it as R1 for the time being. Means references always make it easy for us to locate places. Means when you went to a friend's house some years back and the friend was there with you, on the way you have noticed some reference, and later when you went alone, you took that reference and you could locate the house again easily. So references would make it easy to locate places. So when I say latitude is the angular distance, north or south, it means there must be some reference from where I measure how many degrees a place is on the north or south. So for the time being, I say for north-south distance called latitude, reference is, let's say, R1. Then we'll see today we need one more angle. Latitude won't be alone sufficient because earth is spherical in shape. So we would need one more angle called longitude, and this longitude would be the angular distance of a place east or west. Means how many degrees a place is on the east or west of some other reference, which for the time being I call as R2. Okay. So it means it's clear that scholars who were sitting in this conference, they had to choose what should be our reference R1 and what should be our reference R2. Without this, they could not proceed any further, because they were looking for one common system to locate places on the earth's surface. And one more thing, that since meridians are lines joining North Pole with South Pole, so we had to fix which locations should be our poles. So the third thing they had to decide was that which areas of the world should be taken as poles. So it means, cutting it short, the scholars of IMC, they had to decide in the very beginning of the analysis or everything, what they had to do, three things. One, what should be reference R1, what should be reference R2, and the third, what should be our poles. In the last lecture, or what I have just mentioned a few minutes back, since my earth is bulging out in the middle portion here, so don't you think the area, the location where the earth is bulging out in the middle portion, that becomes a nature's choice for reference R1? Yes, please. It means the best choice was already decided by Mother Nature. It means the scholars who were sitting in this conference, they had no reason to waste time in debating what should be our reference R1. It means it became easier for mankind to locate R1 for the reason that our earth is not a perfect sphere. If earth would have been a perfect sphere, choosing R1 would have been difficult. Second point, we have seen that earth is flattened at the top and bottom. So it means nature had already decided the best locations for poles also. So the scholars of this conference had no reason to waste time on the selection of poles. Again, if earth was not having that misshapening because of spin, then deciding poles would have also been a difficult task. No, if you have one tennis ball and your friend has another, your friend has the same tennis ball, don't think your choice of poles may not match with the friend's choice of poles. So it means it's difficult to choose poles if earth was perfect sphere. So it means in a way it is good that our earth is not a perfect sphere, because selection of poles became easy and selection of reference for angular distance called latitude became easy. Now, let's come to second reference. The second reference for angular distance east or west. So here there was a problem. Now can I say if my left hand is a globe or earth, we can have infinite lines to join north and south pole? And can I say on the face of it, each of these infinite lines would be equally good or bad to be a reference for angular distance east or west? It means the scholars who come from one particular country, they may say this is a good choice because they find this line passes through their country. But the other country's representatives would say, what is wrong with this line? Someone would say, what is wrong with this line? Or someone would say, what is wrong with this line and all that? Yes or no? So it means since we have lots of choices for the reference line called R2 for east-west distances, and you know whenever mankind has choices, there is a fight. So in this conference of 1884, lot of time was wasted deciding what should be our reference for east-west angular distances. But after a lot of hot debates and waste of time, we all know from school days that they finally decided one line, one meridian, which is called prime meridian, but and something else. Say it again. Say it again. Okay, good. We Indians have been calling this place as Greenwich. The correct pronunciation of this word is Greenwich. Means it is a place which is little east of London. So once you are set in life and you go for your trip to Europe, if you look for Greenwich, you will not find, right? Because English people call it Greenwich. It's a small town little east of London. So you all know that finally the scholars of this conference decided that Greenwich meridian, sometimes I'll also call it as Greenwich so that I sound Indian, right? So means it reminds me of school days, but Greenwich meridian is the correct pronunciation, right? So they chose Greenwich meridian as our reference meridian. What is Greenwich meridian? The line which joins North Pole with South Pole, passing through that place called Greenwich. So this line where I have spotted this particular place, Greenwich, becomes my Greenwich meridian, or we may call it as prime meridian, or we may call it as 0 degree meridian, because this is our initial reference meridian. Okay. Now the first question in the mind would be that when there were so many other choices available, then what led to the selection of Greenwich meridian? So at this moment, just to give a brief idea, as we go with the classes, we'll have more understanding of it. If I was to give it in a brief, what are the 3 reasons for the selection of this as our prime meridian or 0 degree meridian? The first reason we'll see is that at this place Greenwich, which is little east of London, there is a Royal Observatory. And this Royal Observatory was already in use as one of the references by the sailors of the world. Remember, in 1884, world came to have an integrated system for locating places. But you know, much before 1884, we had overseas empires, we had sailors sailing in the world ocean. So it means the humanity knew how to locate places on the earth's surface. But the only problem was, before 1884, we had regional systems which were being used by different communities of the world for different areas. It means we had references, but we didn't have global references, but we had regional references. So much before 1884, this place where you have Royal Observatory at Greenwich, this was already in use as a reference. So the English scholars certainly would have argued in that conference that since this is a popular reference point, so why don't you use it for the whole world? So the usage of this Royal Observatory as a reference point in the historical past was one reason which went in favor of selection, right? But you know, there were many other such references in other European countries. So this alone could not have done the job. The second reason, which is generally not mentioned in books, we need to understand by common sense, is that dominance of the English Empire certainly would have favored this selection. You know the time we are talking about, and before it, the most dominant empire was English Empire. So the arguments of the English scholars certainly would have carried more weightage in that conference. So it goes as unstated reason that dominance of the English Empire would have done the job for this selection. But if you just take a pause with me here, the first is a historical reason, second is a political reason, but what we are choosing is technical kind of a thing. So technicalities cannot be decided alone on the basis of historical or political kind of reasons. So we had to have something more important as a reason. So today you will see briefly, and in fourth or fifth lecture you will see much more detail, that the main reason which turned the tables in favor of this selection was the concept of international date line. Now you may recall from your school days that there is one meridian line across which there is a change of a day on the calendar, and that is why it is called international date line. Now I will be teaching this concept in my fourth or fifth class with lots of details, but today let's have a broad idea. Now see, what is longitude broadly at this moment? Longitude is angular distance east or west of what? Of Greenwich meridian. Now let's say roughly at this moment, my right hand is Greenwich meridian. Now when I move from Greenwich meridian towards India, it would be eastward journey. If I move towards North America, it would be westward journey. So let's see how far we can go on the east or west. Can I say if this is my reference meridian and I move towards India, then towards Japan, then further east, further east, further east, further east, further east? This is the maximum I can go. How much is this angle? 180 degrees east. And if I travel from Greenwich towards North America, I can go extreme as 180 degrees west. So it means class understands that longitude, we'll see today little later in detail, it would vary from 0 degree to 180 degrees east or west. Means 180 degrees east or west would coincide on the globe. Means it would make one line only, right? So if this is 180 degrees east or west, after I complete my concepts of time, I'll be teaching in my third or fourth lecture concept of local time and standard time. And with some simple calculations, we will establish that when a traveler crosses this line, depending on the direction in which it is crossed, there is either a gain of a day or loss of a day. Now since for this we need the concept of time, so I can't speak more on this, but you just understand that 180 degrees east or west is a fascinating meridian across which there is a change of a day on the calendar, and this is why this line has been named as international date line. Okay. Now, if you just understand this point that there is a change of a day on the calendar across this line, imagine for a moment what if this line was passing through densely populated areas of the world. Let's suppose for a minute this line was passing through old Rajanagar market right in front of our main building. Don't you think this line would become a nuisance for people? Because we Indians will keep jumping across the line to change our commitments. I will ask for submission of assignment on Monday. Some students will not submit, saying that, sir, we live on the other side of the line. For us, it was Tuesday. So life would become a hell if this line was passing through the densely populated areas of the world. So the scholars who were sitting in that conference, IMC 1884, they were wise people. They could understand these kind of problems of this line before they decided the line, right? Now, I'll make a statement. Let's see how many of you captured it. It's a very easy, simple statement. Now, if my left hand is globe and I say, I choose this line which I'm making with my right hand, this line as 0 degree meridian. Can I say, the moment we choose what is 0 degree meridian, the international date line gets decided? Because whatever I call as 0 degree, the opposite side of it, the opposite arc of the globe would be international date line, right? So now we come to the point that what led to the selection of Greenwich meridian as our prime meridian or 0 degree meridian. One, the historical reason. The second, the dominance of the English Empire as political reason. And the third reason was that scholars of this conference found that when we take Greenwich meridian as our 0 degree meridian, the opposite arc, which is to become international date line, it was passing through the mid of the Pacific Ocean. You know, if international date line passes through the oceans of the world, it would not be a problem for most of the humanity, because more of people live on the continents. Yes, it could be a problem for some people because we do have some population, some communities in the ocean also. But you know, when something is a problem for some communities, we can always give them some special adjustment. So when I'll do this topic of international date line, or you remember from your school days that international date line on the world map has certain zigzag paths as such. So we will see that since the ideal, which was the opposite arc of Greenwich meridian, was passing through the mid of the Pacific Ocean, so it was in general a very convenient choice. And wherever it caused a problem, humanity went for some special adjustment. So it means, cutting it short, I am saying, we went for Greenwich meridian as our 0 degree meridian because it gave us a very convenient choice for international date line, right? Now this all will come in more details. And now, before I go further, let us write a few points which will give us the beginning of this lecture. So please write, keeping all what I have said in the background. Fundamental to geographic analysis. First point. Fundamental to geographic analysis is the development of a comprehensive and logical framework to establish accurate location of any spot on the Earth's surface. Accurate location of any spot on the Earth's surface. Second point, the imaginary grid system You know the lines which are there on the globe, we call it as the grid system. And you know these are not the lines given by nature, we have drawn them. So it is called imaginary. So right, the imaginary grid system is anchored, means it is held, is anchored by the position of the poles, is anchored by the position of the poles and equator, by the position of the poles and equator, which are determined by the Earth's slight variance, means variation, by the Earth's slight variance, which are determined by the Earth's slight variance from a true spherical shape or from a perfectly spherical shape. Earth's slight variance from a perfectly spherical shape. Now, is everyone okay with this second point? That second point tells you indirectly that it is good that our Earth is not a perfect sphere. That variation we have is making the things easier for us. Now write the third, the selection of Greenwich meridian. Third point, the selection of Greenwich meridian as prime meridian. When you write prime meridian, you can write /0 degree meridian. The selection of Greenwich meridian as prime meridian or 0 degree meridian relates to the following three reasons. Relates to the following three reasons. Relates to the following three reasons. Now let's write briefly all the 3 points because they will come again in the lectures. First point, the use of Royal Observatory at Greenwich, the use of Royal Observatory at Greenwich as a reference point in the historical past. As a reference point in the historical past. Second, the dominance of the English Empire. The dominance of the English Empire. And third, you write briefly, details will come later. Please write, a convenient choice for international dateline. Third reason is a convenient choice for the international dateline, IDL in short. Okay, so now with this background, let's understand in next 30 minutes time the 4 concepts, latitude, longitude and lines called parallels and meridians. And based on that we'll build the rest of the lecture. Now see, for making my presentation easier, I would suggest that you keep one apple in mind. Now for my all classes from today onward, if I use apple in my class, you please assume it as a sphere, though it is not, but we'll assume it because it will make things easier. So in most of my classes, I'll take apple to represent my earth. And when I say apple, you'll take it as a sphere, right? And we'll sometimes need a knife also. Knife would refer to a plane. So knife represents a plane and apple represent sphere. And apple will represent our earth in lectures of geography. At least the areas which I'm going to teach, it would be a good kind of a choice. Now there may be some student who may say, sir, orange is more spherical. Why do you take apple? Then for the timing I'll say, I'm the teacher, not you. I'll decide the things, no? Right? I'm the boss here on this side. So choice would be from the teacher, and there must be some reason for it, okay? That orange may not serve the purpose in the kind of things I have to teach. Now, so, yes, you want further cooling? Increase कर दो ना, कितना temperature? 24 कर दो. See, basically, we wish that you must chill in our classes. We teachers are not confident to the subject that whether we'll be able to make you chill or not. At least through temperature we can do so. They have their own technicality. See here, let me tell you, it's the beginning of the course. You please come with little extra clothing if you feel cold. No, try to understand the point. When you have large number of students in a classroom, if we do not have this cooling, then oxygen levels go down. It might be a problem for someone sitting in the class, but more for the teacher, because we have to stand and speak for 2.5 hours, and we do it generally 3 times a day. Okay? So for oxygen levels, we need this cooling, and in fact, this is now we are going to summer. Even in winter, we keep the same temperatures. Okay? We really chill throughout the year. So you please take care of your clothing, etc. See, even I feel cold, but there is no other option, right? Now, so let us go for understanding these 4 concepts through some diagrammatic presentations. Notes will come where I dictate. You just focus on what I'm doing on the board, and you keep doing it in your notebook also. So we'll start with an apple and a knife to understand the 4 concepts: latitude, longitude, parallels, and meridians. My board is 2-dimensional, your notebook is 2-dimensional. When we represent a sphere on the board, it would become a circle. So what I do is, I make this big circle to represent the apple on the board. This is my apple, you do it for your own notebook also. So make your apple on the notebook. See, best for a student is always, not only in my classes, in all teachers' classes, a good student is one who will be 1 step behind the teacher. Okay? Right? It means focus on what I am teaching on the board rather than having questions in mind, what has not come so far. Okay? So be a step behind the teacher, learning will be always good. And whatever I do on the board, once I have done it on the board, then you could do it in your notebook. Okay? Those students who jump like a frog ahead of the teacher, and that too in such a large class, teacher cannot catch them, no? So be a step behind, and learning will always be good. And remember, learning needs a sequence. So anyone who breaks the sequence will not benefit much. So now, if this is my apple, with the help of a knife, I mark the middle portion of this earth. And I do it little, means I'll just go for a curved kind of a line, so that you get the feel that it's a sphere. So I draw this line to show the middle of the earth. You also do that. Now, with the help of the same knife, I draw the shape of a slice on this apple. So I run my knife from the top to bottom like this, and I do it on this side also. You also do that. Now, imagine that we cut the upper half of this slice. So imagine I run my knife deep in this portion and take out the upper half of this slice. The moment I take the upper half of this slice out from the apple, I'll be able to see the location of the seed of the apple. If apple is my earth, the location of the seed can be taken as center of the earth. Okay, I hope now you understand why I didn't take orange. There have been too many centers, no? Apple generally has more. So let us say this is that location, which is the seed location, and I represent it by C. C would indicate center of the earth. So if apple is my earth, then this is the center of the earth. Is okay? Now, what is our task? Today, in next 25-30 minutes time, we wish to understand the address of a place in terms of two angles, latitude and longitude. And then based on that, we'll go for two lines called parallels and meridians. So it means we first need to have a place so that we can develop an address for it. Since I'm doing this lecture in India, so I choose a point in North Hemisphere. Northern Hemisphere, you understand? That if I cut my earth through the middle, we have two parts, the two halves, Northern Hemisphere and Southern Hemisphere. So let's say I choose this point and I name it as P. You also do the same. Choose a point P the way I have done it on the board. So it means what is our task for about 30 minutes now? That I need to develop two angular distances, latitude and longitude. The convention of my subject is that whenever we mention the address of a place, first we'll write latitude of that place. Means we'll mention to the reader that how many degrees this place is, north or south of the middle portion, which I'm going to call as equator today. And then after that we write the longitudinal distance, that how many degrees the same place is on the east or west of Greenwich meridian. We have already chosen Greenwich meridian, right? Remember, two references are already there with us. The middle portion of the earth, where the earth is bulging out, is the equator, and the Greenwich meridians are prime meridian. Okay? Now, so what I suggest to make my presentation easier after this is, I ask my class to mark this point. Let us say we mark it as A here and this point as B. And please confirm the understanding. Can I say everyone understands from the diagram, A and B are the 2 points on the earth surface right in the middle of the earth. Okay. So A and B are on the earth surface right in the middle of the earth. C is the inside point, that is the center of the earth, and P is another point on the earth surface for which we need to develop the address comprising two angles, latitude and longitude. Okay. Now what is latitude? Broadly speaking, latitude is the angular distance north or south of that plane which cuts my earth through the middle, and this plane would be called as equatorial plane. So think of it, if my left hand is the earth, imagine a plane which cuts the earth through the middle into two halves, north hemisphere and southern hemisphere. So this plane which cuts the earth through the middle is my plane called equatorial plane. From this plane we measure how many degrees a place is in the north or south. Now, to reach to this equatorial plane, I suggest my class that join the center of the earth with the point A. Please join C and A. Let's see what happens. Now, let's have one clarification before we go further. Since my board is two-dimensional and your notebook is also two-dimensional, so you'll get a feel that as if CA, the line segment CA, is inclined. But those who are holding apple in their mind, they know CA in three-dimensional frame is not inclined, it is horizontal. Is that okay for everyone? Means see here, if I make my right hand fingers look like a upper half of this slice, when you took the upper half of this slice, this portion was flat. So it means line segment CA is not inclined, it is plane, it is horizontal. So let's say this left hand represents the line segment CA. It means here is the point C, the center of the earth, and this tip of the finger is A. So is everyone okay that in the apple CA is like this? Now from this plane, which is called equatorial plane, I measure how many degrees a place is on the north or south. So is everyone okay? CA is the equatorial plane of the earth. Now, let us take let me take on my right hand this tip of the finger as point P. Okay, so let's be clear. What is this point? C, the center of the earth. This is A of my diagram, and this is P, the point for which we will develop the address system. Now, imagine if I keep my right hand over the left hand, can I say P coincides with A? It means P is right over the equatorial plane. It means at this moment it has no distance. Remember, we are measuring which distance, north or south. At this moment, can I say latitude of P is 0 degree? Because it's right over the equatorial plane. Now, if I move my right hand over the left hand, so how much P is going away from the equatorial plane? Can I say this angle at this moment? More of this, right? So if I have to show this P, which is there in the diagram, can I say I can open my two hands like this? Yes, please. This is C, this is A, and this is P. Okay. So this angle is the latitude of P. Now, can I say this angle in my diagram will be represented if I join C and P? So please join C and P. Let us say this angle is X degrees. And on which side P is, north or south? It is taken on the north. So it means we can say latitude of P is X degrees north. Means how much away P is on the north of the equator. In my diagram it is X degrees. Now, if someone asks me, sir, how much would be the maximum variation of latitude? I come back. At this moment, what is latitude of P? 0. How much is the maximum variation? It is 0 to 90 degrees north. When it is 90 degrees north, it becomes north pole of the earth, right? Now, if I was doing this lecture in Sydney for Australian Civil Service examination, I would have been taking up points P in the southern hemisphere, and I would have been teaching my Australian students like this. Yes or no? This is X degrees south, or maximum I can go for is 90 degrees south, the south pole of the earth. Okay, so class understands latitude is the angular distance north or south of the equatorial plane, and its variation is 0 to, yes please, 90 degrees north and south. We'll write the notes later, just follow me in the board. Is latitudinal angle understood? Now, be on the board and think of the next point. Can I say, if someone knows only the latitude of P, that it is X degrees north of the equator, he or she cannot reach P. Means this is an incomplete address. It is something like your friend on phone says, I live in Calcutta, next time when you are in Calcutta, do visit me. He repeats this sentence 10 times and then switches off the phone. Don't think he has given you a beautiful address so that you should never be able to visit him. It means he never wanted that you should come to his place. So it's something like, if I tell you the latitude of P and I say attempt going there, you will not be able to reach. Why latitude is an incomplete address? Because you can understand there are thousands of points all around the earth surface here which have the same latitude as that of P. It means by just knowing latitude of P, I can't reach there, because there are many points on the earth surface which have the same latitude of, yes please, X degrees. Those who are not getting my point, let's try to understand in a rough fashion. Let's say again, C, this is A and this is P. I open my hands to make the present P of the diagram. Is okay? Now I'll hold my left hand stationary so that you can focus on this main point P. So this is which point? P. Now, as I move my right hand, you will see that this tip of the finger will trace many points which are like P, having same latitude as that of X degrees north. See here, if I rotate my hand like this, wherever this tip of the finger is going, what is the latitude of that place? It is X. So I am holding it constant here. Please understand fast, I can't do more. So all these points which are there, all around the earth surface there, they have same latitude as that of P. So I can't reach P with this incomplete address. Now, it means class understands that on the spherical earth, we can reach a point only when we have the other component also, which is east-west distance, right? That is called longitude. But before we do that, let us develop a concept called parallel. What is parallel? You know there are thousands of points which are there with the same latitude. If I join them on the globe, those points which have the same latitude, I get a line called Parallel. So parallel, we'll be writing very soon after this, that parallel is a line connecting places of same latitude. For example, now is the moment we can define technically. Can I say equator is 0 degree parallel? What is equator? The line on the globe which joins all places with 0 degree latitude. Those who are not able to visualize, let's see. If this is C, this is A, I bring P over A. What is the latitude of P now? 0 degree. So see, I rotate my right hand over the left hand. Now wherever this P is going, this tip of the finger is going, it is tracing what? It is tracing equator. And the plane here is equatorial plane. So equator is the 0 degree parallel, means the line joining places of 0 degree latitude. Now someone will have a question that, sir, why are we calling this line of latitude as a parallel? Then the answer is easy, that if my left hand is a globe, I draw 0 degree parallel, I draw 10 degrees north parallel, I draw 40 degrees south parallel. All these lines of latitude are running parallel to each other. So since all lines of latitude run parallel to each other, so the scholars gave this term parallel. Okay. So is everyone okay with the concept of latitude and parallel? So please write this. Yes. What? No, that's what I'll tell you at the end of this story. Now, since you have asked me, so I answer it here. He says, can I use latitude and parallel interchangeably? We sometimes in our school days did that. Sometimes our teachers also did that. But once I would have completed all the 4, I would have given this caution. We should never use them interchangeably, because we have understood this is an angle and this is a line. And do remember here, I'm saying parallel is a line. But many of you will visualize that on the globe it is going to be a circle. Yes, please. What is equator? A circle. So when we are, remember, most of the time we are doing these things on a notebook or on the board like this. So since the things are being taught and done more on the 2-dimensional frame, so nothing wrong, we call this parallel as line. But wherever need be, we can see them as the circles as they are on the globe. Okay. So very soon in the next part of the lecture, you will see that I'm going to see these parallels as circles also. But when we talk about general things in 2-dimensional frame, I'll keep using the word line. But as I have answered earlier, we should never use latitude and parallels interchangeably, and similarly longitude and meridians will also not be used interchangeably. 2 are angles and the other 2 are lines on the globe. So please write a few points on what we have done. First point, latitude is the angular distance. Latitude is the angular distance measured north or south of the equator. Measured north or south of the equator. Now, just take a pause here. Now I'll make you write a sentence which will relate to this diagram. So whatever you write, trace it to this diagram. So write the next point. We can project a line. We can project a line from a given point. We can project a line from a given point, and just take a pause here. What is given point in my diagram? P. So within bracket you keep writing what the point which is being mentioned. So write from a given point P on the earth surface, from a given point on the earth surface to the center of the earth. What is center of the earth in my diagram? C. So write within bracket C. So I repeat, we can project a line from a given point P on the earth surface to the center of the earth, that is C. Then write further next sentence. The angle between this line means PC, this line PC. The angle between this line and the equatorial plane. What is equatorial plane? CA. So write with bracket CA. the angle between this line means PC and the equatorial plane, that is CA, is the measure of latitude, is the measure of latitude of the given point P, is the measure of latitude of the given point P. Next point, latitude varies from 0 degree, latitude varies from 0 degree to 90 degrees north and south. Latitude varies from 0 degree to 90 degrees north and south. The term parallel. Parallel is a line connecting all points of the same latitude. Parallel is a line connecting all points of the same latitude. In the same point, write next sentence. It is called so as all lines of latitude run parallel to each other. It is called so as all lines of latitude run parallel to each other. As all lines of latitude run parallel to each other. Then write one more point, separate point. Please write 0 degree parallel is called equator. 0 degree parallel is called equator. 0 degree parallel is called equator. Now be on the board for the next section. Now since you already know that this is an incomplete address, so we need to also mention how many degrees this place P is on the east or west of the Greenwich meridian. Since I am doing my lecture in India and we are in the eastern hemisphere, so I keep Greenwich on this line so that P becomes on the east of this Greenwich meridian. Let's say this place here is Greenwich. So it means this line which joins North Pole with South Pole is called as, yes please, Greenwich meridian, or we can call it as 0 degree meridian, or we also call it as prime meridian. Okay, so please mark Greenwich the way I have done on the board. So I now need to show that how many degrees P is on the east of Greenwich, yes or no? And similarly, we can do it on the west also. But since I am doing it in India, so I am keeping P east of Greenwich. Now, let's understand some simple things. See here, if this place is Greenwich and this is my reference for east-west angular distances, so can I say all points which are on this line, they would have no angular distance east or west of the Greenwich? If Greenwich is my 0 degree meridian, 0 degree value location reference, so can I say all points on this line which is joining North Pole with South Pole and passing through Greenwich, can I say all points of this line have 0 degree longitude? Yes please. So it means in my diagram I need to tell how far P is from this line. But before I do that, can I say similarly all points which lie on this line would have the same longitude as that of P? Yes please. So this is having all points with the same longitude as that of P, and all these points have the same longitude as that of Greenwich. So it means first we can think of the line itself so that it becomes easier for us. What is meridian? Meridian is a line joining places of same longitude, right? So this is Greenwich meridian, 0 degree meridian, right? Now, for a rough representation, please take my right hand representing Greenwich meridian. Okay. So from this right hand, I measure how many degrees you are on the east or west. So to represent the diagram, I open my right hand on the east towards India, like this. Now let's say on right hand is the place called Greenwich, and on my left hand there is a place called P. What is the separation between the two? The angle which my two hands make. So can I say, who says 30? Very good. He says 30. 45. So this is very right. This is the angle, right? Now, can I say this angle, which is representing the longitude of P, would be visible in this diagram if I join B and C, and the angle would be BCA. So please join B and C and see what happens. So please join B and C. And this angle, please tell me, is this understood? This angle is the separation between the meridian, which is called Greenwich meridian, and the meridian on which P is located. Let's say this is y degrees, and you know I have already assumed it to be on the east. So it means class understands, for reaching P, you need to do two travels. One, you have to travel x degrees north of the equator, and at the same time you have to move y degrees on the east of Greenwich. Okay, so this becomes the complete address for the place. And as I've already mentioned, what is maximum variation of longitude? If this is my Greenwich meridian, how far I can go on the east? 180 degrees east, and same way I can go for 180 degrees west. So longitude would vary from 0 to 180 degrees east or 180 degrees west. These two will coincide, and after doing the concepts of time with some simple calculation in my fourth lecture, I'll establish this line to be the international date line. We'll be doing this topic in detail in fourth or fifth lecture, right? Now, this is what we had to learn on longitude and meridian. But someone may ask me that, sir, what is the significance of the word meridian? Now, and this has been asked by UPSC also in its public exams many times, that what does word meridian indicate? Now see, I can respond by saying that the term meridian relates to the concept of time, and I'll teach time in the third or fourth lecture, okay? So I can postpone this discussion, but generally I don't do that. So what I'll do is, after making you write notes on longitude and meridian, I'll discuss for 5-10 minutes the term meridian in relation to the concept of time. But this will come in more detail in the lecture on time. So first you write the longitude and meridian notes, and then I'll take you further. There's a student who wants perhaps me to repeat this longitude. See here, we are saying longitude is how many degrees you are on the east or west of Greenwich meridian. So I made it simple by saying in a rough way, if my right hand is the Greenwich meridian, how many degrees you are on the east or west of it. In this diagram, if my right hand is Greenwich meridian and left is where the P is located, I say this angular distance is longitude, which is represented by the angle BCA, and which I have shown as y degrees on the east. So please write a few lines on this. Longitude is the angular distance between the meridian. Longitude is the angular distance between the meridian passing through a given point and the Greenwich meridian. Then right, one more sentence, the same point. It is measured east or west. It is measured east or west of the Greenwich meridian. Whenever I say Greenwich meridian, you can take 0 degree, means you can write prime meridian or 0 degree meridian, right? It is measured east or west of the Greenwich meridian. The right. Next point. Longitude can vary from 0 degree to 180 degrees east or west. Longitude varies from 0 degree to 180 degrees east or west. Then write one sentence for meridian. Please write, meridian is a line joining places with the same longitude. Meridian is a line joining places with the same longitude. With the same longitude. Places with the same longitude. Okay, so we have understood latitude and based on it the line called parallel, longitude and based on it meridian. And as already suggested, we should never use these terms interchangeably. These are two angles and these two are lines. In school geography, many of our teachers used to make this mistake. But at this level, we should be mature enough not to go for the use interchangeably. Now, let us have 5 minutes or 10 minutes discussion for the word meridian, but it will be more in detail in my 4th lecture. So be on the board and don't write anything. See here. You know from school days that under time we have two concepts, two sub-concepts. One is called local time, which is the base concept. And based on local time, we have standardization of time. So we have the second concept as standard time. I can make you understand the concept of local time. I can make you understand the meridian with the help of local time concept. Standard will come in the 4th lecture. Now see, as the term indicates, by local time we mean the time for a particular place. Now, how do we get the time for a particular place? If I fix my watch for Karol Bagh in relation to the sun's position in the sky, then that watch will show me local time of Karol Bagh. So, when I fix my watch for a place like Karol Bagh in relation to sun's position in the sky, then that time is local time. When I say this, many of you may have a reaction in mind, sir, we don't fix watches like this. The reason is that for most of the functions in our life, these days, in the modern period, we are using standard time. We are using one common time in the whole country. So that is why we are not fixing watches in this local perspective as such. But sometimes we might have to, because you know, we fix or we use local time generally these days for religious rituals. For secular functions we use standard time, but for religious purposes we still use in many places of the world local time. So let's just have hypothetically this point, that next year, let's say somewhere in the month of April, you may come to understand that neither the classes have done anything great and nor you have done yourself anything great in the room, and prelims is right on your head. So then the only way out would be that you may go to a priest in this area and tell the story that I wasted a lot of money there, lot of my time, but I have not been able to reach to anything and my prelims is very close. Then the priest will say, pay me another fee. And we'll both go for making some rituals and we'll seek divine intervention on the day of prelims. So to seek divine intervention, you will have to perform some religious rituals. The priest will ask you to come for 7 days, next week, 1 week, at an appointed local time to perform those rituals, because they generally are done with local time. So then you will have to fix your watch to Karol Bagh's time. How would you do that? You know from school day science. Local time is 12 noon. When? Complete the sentence. What is 12 noon local time? 12 noon local time is the moment of the day when sun is, give me the word. Very good. So many of the students are saying when the sun is overhead. This was the word you said. Now, very good. The term overhead is given in school books, but I would not prefer this. In the next part of the lecture, after some time, we'll understand better than overhead would be, though it's a term used in school books, better would be highest. So, 12 noon local time is the moment of the day when the sun is highest in the sky. Because in the second half of the lecture, I'll make you understand that sun cannot be overhead in the entire world. There's only a limited area of the world between the two tropics. You might have heard of Tropic of Cancer and Tropic of Capricorn. So in the second half of the lecture, we'll understand some basics today, where you'll find that sun can have overhead positions only in tropical area of the world between the Tropic of Cancer and Tropic of Capricorn. In the rest of the world, sun will never be overhead. But the whole world has 12 noon local time. So better word would be highest. Highest means it might be perpendicular in overhead position. In some other places, this highest may not be overhead position, right? But general definition would be better with highest. But in school days, they made it easy for the student to understand as overhead. Now, how do I get to know what is that moment of the day when the sun is highest in the sky? You know from school days experiment, if I keep an object on the road and wait for the moment when the object casts the shortest shadow, then I'll get to know that the maximum inclination angle has been achieved. So that moment of the day when an object will cast shortest shadow means when the sun has reached highest is called 12 noon. Is okay? Now, let's leave it here and go into history. You know, Greeks were the pioneers in many subjects for the reason they had lot of intellect, they had versatility of knowledge, they had a lot of curiosity always to know more about the nature they were living in. But after Greeks, we had the empire by Romans in Europe, and there was a basic difference between the two. Romans were more practical people. They were not much into studies. They were more in business, and they were more in making their empire the largest of those times. And they did succeed in that. So, you know, people who are more practical, those who are more in business or more in administration, for them time is more important. No? So, Romans became great experts in time. And to tell time in their entire empire, they were building what are called as sundials. You know, in Jantar Mantars we have such structures through which we get to know over the local time. So Romans were expert in making the sundials for the concept of time, to tell time. And these Romans gave primacy to 12 noon local time. So to tell time, they gave primacy to 12 noon local time. Means they use this as reference time. And to indicate 12 noon local time, these Romans use the term meridian. So technically speaking, the word meridian indicates 12 noon local time. Now, meridian comes from two Latin roots, meri plus dime. Meri in Latin language is about sun's highest position. And dime in Latin means a day. So what is meridian? The moment of the day when the sun is. Now there are some students writing these notes. I'll make you write the same notes again. Okay, so wait, I see we made a rule in the first lecture or not? When I speak, you will not write because I feel neglected. So see, let it be a sequential approach. Like first I speak, then I'll make you write. Okay. Now, Meri is what? Sun's highest position. Dime is a day. So what is meridian? Moment of the day when the sun is highest in the sky. It means 12 noon local time. And this is what the world is using even today. What is anti-meridian? It is AM, before noon, and PM is post-meridian. So what world uses today was given by Romans. Now you will still have a question that why are we using this word meridian for a line? So in the lecture on time, in the fourth lecture, we'll find, now mind this, if my left hand is a globe and I make one meridian, so we will see all places which are on a given meridian, they have same relationship with the sun. It means all places on a given meridian will have same local time. So since all places which we have designated on a meridian have the same time, so we took that term from the Romans for the concept of time to indicate that line also, okay. Now, just to add, but it's not required today. So look at, let me take my left hand as globe now. In the fourth lecture, I'll go for simple calculation. I'll say Earth spins once in 24 hours. Now spin means what? The 360 degrees of longitude being covered. So we would equate 360 degrees of longitude to 24 hours. And this will give us 1 degree of longitude representing a time difference of 4 minutes. It means two places which are separated by 1 degree of longitude, they have a difference of 4 minutes in terms of local time. Then we'll bring the idea of direction also. You know, my earth rotates west to east. East you have the sunrise earlier. So east you are ahead and west you are behind. So using these two rules, we'll be calculating time for the places and other related things, and we'll reach to international dateline and many other side things, okay. But today I believe you have understood the word meridian. So write on the margin, because this is not the main discussion today. So write on the margin. The term meridian was given by Romans. The term meridian was given by Romans to indicate 12 noon local time. 12 noon local time. Put a hyphen. The moment of the day, that is the moment of the day, when the sun is highest in the sky. Moment of the day when the sun is highest in the sky. That's all for this this section. Now, if you have understood all the four things, latitude, longitude, parallels and meridians, so the grid, the network of these lines of parallels and meridians is what we call as grid system. Now, let us go for a concept from mathematics to be used in geography classes. Now, I'll take you to the concept called great circle. Please write this title, great circle. Now, there is a student Tushar writing about that India's time is 5:30 hours and that means 5.5 hours and all that. Please, I said, you be a step behind me, no? So, I'll discuss this in the details of time, because standardization of time will make us understand that 5.5 hours gap and all that. Now I'm going to discuss a concept from mathematics called great circle, which will have applications to present lecture and my future classes also. So please don't write anything, listen to me. We are going to have a long discussion. From great circle, I'll move on to some elements of seasonality also, okay. Now there's a student Ria asking me, there are how many total longitudes and latitudes on the globe? See, you can have any infinite, means you can go for any small division of latitude or longitude. So, though we are saying the longitude varies from 0 to 180 degrees east or west, but you think if we go for breaking up a degree, then you can have infinite subdivisions, okay. So, answer would be infinite kind of subdivisions, But answer would depend on the kind of choices given to me, the way the examiner wants, okay? But if I keep breaking my degree into smaller parts, you have anything possible. Now, let us understand what is great circle. For this section also, you will keep apple in mind. Apple means, yes please, a sphere. And I'll need one knife again. Knife will represent a plane. Now listen to me carefully. If my left hand is a sphere, means I'm taking it as an apple. If I run the knife, the plane, through the apple anywhere to cut it into two pieces, I repeat, when I run the knife through the apple anywhere to cut it into two pieces, can I say the intersection, the plane and the surface of the apple will give me a circle? Means when I cut the apple into two pieces by running the knife anywhere and I show you those two pieces like this, you will have a circle being formed. Yes please? Is it okay? So that is what we are going to. But now let's see what is great circle. If my left hand is a sphere, means the apple in my presentation, and if I run this knife, the plane, through the center of the apple, means center of the sphere, to cut this sphere into two halves, can I say in that case the intersection of the plane and the surface of the sphere will give me the largest circle for this sphere? Yes please? And this larger circle, which is dividing the sphere into two halves, will represent the circumference of the sphere. Yes please? This larger circle, which I get by running the knife through the center of the sphere, which is representing the circumference of the sphere, is what mathematicians call as great circle. Is okay? So when I run my knife into the apple, the sphere, through the center to cut into two halves, the circle which I get will be the largest circle possible for that sphere, representing the circumference of that sphere. This circle in mathematics is called as great circle. Now those who have understood, please tell me, for a given sphere, how many great circles are possible? Very good. Good. Everyone said infinite. Good. Means if there is a sphere, the apple, you can run the knife in n number of ways, but the only thing you have to ensure is that must go through the center, no? So when you run the knife through the center, you get a great circle. And how many ways you can run the knife through the center? Infinite ways. There is one student writing one. It means that Tushar has never cut the apple of his own. He has been getting it from the parents or someone else. Those who have been cutting their apple of their own, they know you can run the knife like this, vertically or at any other angle. The only thing you have to ensure is knife must pass through the center. So it means, class, understand, there are infinite great circles for a given, yes please, sphere. Is okay? Now when we have a concept called great circle, there is also an associated concept called small circle. Now what is small circle? When I run the knife through the apple anywhere other than the center of the apple, then the circle I get will be called as small circle. Now those who are not getting it, recall that day when you had only one apple at home and you had to share with your younger sibling. You said, I am the elder one, I'll cut it. So you took the apple, you took the knife, and you showed to your younger sibling that, see, I'm putting it right at the center, we'll have equal share. And you did that, but the moment you were about to cut, you lifted the knife. No? So that circle which you got by your lifting the knife was a small circle. Okay? Now, she wants me to repeat the infinite number of great circles. See here, we are saying for a given sphere, how many great circles are possible? It means I'm simply asking if there is a sphere, in how many different ways you can cut it into two halves. Answer is n number of ways. Because when you have to cut the apple into two halves, the only thing you have to ensure is knife must pass through the center. Those who think of one as the answer, they cut the apple like this only. Some students, they give two, they cut the apple like this also. But you can cut the apple into two halves in any number of ways. The only thing you have to ensure is that knife must go through the center. Okay. So there are infinite great circles for a given sphere. Now, let us apply this section to our previous part of the lecture. Can I say, based on whatever we had done till now, can I say of all the parallels of the globe, equator is the only great circle? Means all other parallels other than the equator are small circles. Is okay for everyone? Now, if this is understood, now there is a student, Tanvi says that we'll get only one circle by cutting it at one place. Basically, I'm saying don't cut it. Just imagine cutting it, okay? Means my question was, how many great circles are possible for a given sphere? Okay, so don't cut the apple, just imagine cutting it. Now, let us go for, now there is a student Tushar again running ahead of me. He says it means Earth has only one great circle. You please wait. I'll have infinite great circles. You just wait. I said for, means if I apply to the previous part of the lecture, of all the parallels you agree that equator is only great circle. All other parallels are what? Small circles. Now we come to meridian. I make a statement, please think of it. And remember, we are assuming Earth to be a perfect sphere. If I don't say anything, Earth is a perfect sphere. So now I say each meridian makes half of a great circle. So my notes will put it little technically, will say each meridian makes a semi-great circle, means half of a great circle. Those who are not getting my point, if my left hand is the globe, if I join North Pole is South Pole, it is half of a great circle. Why? Because if I take the other side, the opposite arc, the counter side of it, can I say both will make a great circle? For example, today you got some hint of 0 degree and 180 degrees. So if this is 0 degree meridian, what is on the opposite side? 180 degrees meridian. If I take 0 degree and 180 degrees on the other side, both will make what? A great circle. So it means each meridian makes half of a great circle, that is semi-great circle. But when you read some school book like G.C. Leong or NCERTs, for school books, for school children, authors make it little simple. They say all meridians make great circles. It means the school author is taking for every meridian the opposite arc also. So if you take for every meridian the other side also, then it would make a great circle. So school books statement is okay in general, but to make a more precise statement, better is that each meridian makes semi-great circle, okay? So I repeat the conclusions, that of all the parallels, equator alone makes a great circle. Other parallels other than the equator are what? Small circles. And each meridian makes half of a great circle, that is semi-great circle. But school books will make it further simple by saying that all meridians make great circles, means they are taking the other side also, okay? Just to not, means I should not share, but this is another Tushar, he says, ये कौन तुषार है जो मेरा नाम खराब कर रहा है, right? I tell you, you have all kinds of people. Don't write these kind of comments here. Let's rise little higher, right? कोई किसी का नाम नहीं खराब करेगा, right? We are all like a family here, right? And if I say about any particular student, he or she also should not mind, no? I'm little elder by 5-6 years, so I can always say something. So being the elder in the class, I can always make a comment for a student, no? So, but there's nothing with any, remember, teachers always need, or teachers always wish good things only for the students here. Now, let us now go for some future applications of this concept of great circle. But let me make one clarification before we start this part of the lecture. In my 16th lecture, I'll be having a very interesting topic, reasons for seasons. It means we'll see what causes seasonality on my earth. We will see in that lecture what are the 5 reasons for seasonality. But remember, it will be which lecture? 16th lecture, right? But before 16th lecture, I would need some elements of seasonality. for other topics of the syllabus. So from today onward, I'll give you some broad elements which relate to seasonality. But I will not disclose the base that what are those reasons which cause seasonality. It means you focus on what I teach, but this curiosity of yours that which are those reasons causing seasonality, that would be taken up when the right time for it comes, because sequential approach would be better, right? Now, so let us understand some elements, and whatever I'll teach you in the next about 20-25 minutes, it would be established further or consolidated further with some diagrams, some sketches from the handout, okay? So first let's visualize the things and understand some basics, and then we'll consolidate that learning by the end of the lecture. So please see here. As Earth revolves around the Sun in 1 year's time, we will see that at every moment of this journey, the sunlight cuts my Earth always into two halves. So think of this, that as my Earth is going for a journey of 1 year around the Sun, the sunlight will always cut the Earth into two halves. One called the light half, the day, and the other half, the dark half, called the night. So if you take my left hand as the Earth, and the portion of my left hand towards you as the light half, and the portion towards the board as dark half, can I say the edge of the light half would be a great circle? Yes, please. And this great circle, which is given to us by Mother Nature, is called in science as circle of illumination. So please visualize once again, those who don't those who are missing it. I repeat, as my Earth revolves around the Sun, at every moment of this journey of 1 year, the sunlight cuts my Earth always into two halves. The light half called day and dark half called night. The edge of the light half means sunlit hemisphere. The edge of the light half, which is nothing but a great circle, is named in science as circle of illumination. Okay. So nature has given us a very good example of great circle. Now let's leave this and see one more point. As Earth revolves around the Sun, now there is a student provide the definition of great circle. I'll give all notes. So be focused on the board. I know what I have to give in the notes, okay? So please, if you write such kind of comments on the screen, it distracts me from the presentation. Till this moment, have I missed any notes? So then I know my responsibility. So please be what I have missed, just be on the board. See, I woke up at 4 o'clock, mugged up the lecture, and such kind of distraction are making me not let me have a proper vomiting. Okay. I'm just, so let me have a structured vomiting. Okay, I try once again. As Earth revolves around the Sun in 1 year's time, because of some 5 reasons, which I am not going to disclose today, the relationship of the Earth and the Sun will keep changing. So think of this sentence, means one sentence which will make you understand the whole chapter of seasonality will be this only, that as my Earth revolves around the Sun, for some reasons, the relationship of Earth and Sun will keep changing. And you know, when relationships change, see, someone has understood. When relationships change, something happens. So if you ask me to sum up the whole lecture of seasonality in one sentence, then this is that sentence, that seasonality is a consequence of changing relationship of Earth and Sun. Okay, this is the statement summing up the whole chapter of seasonality. Now, if you have a question that, sir, why does the relationship change? That we will not discuss today. But you take the fact that as Earth is going around the Sun for some reasons, the relationship of Earth and Sun is changing. And the consequence of this changing relationship is the seasonality for us. Is okay? Now, when I say relationship of Earth with the Sun is changing, now let's visualize what is that. It means Earth is orienting itself to the Sun differently at different times. I repeat, Earth is orienting itself to the Sun differently at different times. So imagine one object is orienting itself to the light differently at different times. Don't think the light will cut that object differently at different times? Yes, please. So take your time to absorb this, that some object is orienting to the source of light differently at different times. So the light will have to cut that object differently at different times. Now, let's leave this also. Based on your life experience of nature, can I say seasonality gets manifested by changing length of a day? When darkness starts prevailing earlier in the evening, it's a signal that we are approaching winter. Days are getting shorter. So winter is a time when the days are shorter, nights are longer. Summer is a time when days are longer and nights are shorter. So changing length of a day is a signal, is a manifestation of seasonality. Is okay? Summer is a time of the year when days are longer. Winter is a time when the days are shorter. Now the question is, what decides the length of a day? The answer is, the length of a day depends upon the fact that how circle of illumination, means sun's light, cuts my earth. So the way the light of the sun will cut my earth into two halves, that will decide the length of the day. And that is a manifestation of seasonality. Okay. Now, I'll make a statement. You please attempt understanding it, and as we go with the lecture, within a few minutes, you'll have clear consolidation of this today. I divide this statement into two parts. First part you all have already understood. I say, circle of illumination, being a great circle, always cuts my earth into two halves. Yes, please, is it okay? I repeat, circle of illumination being a great, it means, I'm saying, please take circle of illumination like a knife. So what is this knife doing? This knife, since it's a great circle, it always cuts my earth into two halves. Is it okay? But now I make one more part that is more important for you to understand. Now I complete my statement. I say, circle of illumination being a great circle always cuts my earth into two halves, but it does so differently at different times of the year. But it does so differently at different times of the year. It means light, the circle of illumination, is cutting my earth differently at different times. Why? Because you have been told in the background, the earth is orienting itself to the sun's light differently at different times. If the object is orienting itself differently to the source of light, light has to cut that object into two halves or any particular thing differently. Is that okay? So, those who are still not getting clear, let's understand through with my hands and pens, and finally we'll have the consolidation of this through the diagrams in the handout, and we'll reach to some important conclusion for today's lecture as well as some future classes. Now everyone is familiar with the term axis of the earth. What is axis? Imaginary line joining North Pole with South Pole passing through the center of the earth. So I repeat, axis is the imaginary line joining North Pole with South Pole passing through the center of the earth. So I say, take this pen to be the Earth's axis. Now when I say this is Earth's axis, it means immediately you will visualize a globe around it. Okay. Now, as Earth goes around the sun in 1 year's time, at every moment of this journey, or every day, I say, let's put it this way, as Earth goes around the sun in 1 year's time, every day the relationship of Earth and sun keeps changing. But daily changes would be small, would be minute, so we may not be able to comprehend them that clearly. So the scientists of the world will make us understand changing relationship of Earth and Sun on 4 important days of the year, which in the lecture of seasonality I'll call as anniversary dates of Mother Nature. So I repeat, as Earth goes around the Sun in 1 year's time, every day the relationship of Earth and Sun will keep changing. But since daily changes are minute, will be not so easy to comprehend, so scientists will make us understand the changing relationship of Earth and Sun on 4 important days of the year, which we'll call as anniversary dates of Mother Nature. And you all know these anniversary dates. 2 of them are called solstices and 2 are called equinoxes, right? Now, let us understand the relationship of Earth and Sun on 2 solstices and 2 equinoxes. Now, before we reach to that, let's have one more addition. As Earth is going around the Sun, the relationship of Earth and Sun is changing. Mind this sentence now. Since there is a change of relationship of Earth and Sun, it would appear to us as if Sun is also moving. So think of this, that since the relationship of Earth and Sun is changing, so it appears to us as if Sun is also moving. It means now you keep one more element in mind, that as Earth goes around the Sun in 1 year's time, there is Sun's apparent movement. Means Sun is not moving, but it appears to move. So let's first see what is that apparent movement of the Sun. And as I go further with my presentation, you'll understand how it is happening. And then I'll consolidate the learning with these sketches also. See here. If I represent my Earth in 2 dimensions, it becomes a circle and equator becomes a line here. Is okay? Now, when we have summer in Northern Hemisphere, we will understand today in this discussion that Sun appears to move towards the north of the equator, and approximately on about 21st of June, the Sun would reach the farthest position in the Northern Hemisphere. So Sun's apparent movement would be farthest up to the angle, the latitude 23.5 degrees north. And the parallel which joins all places of 23.5 degrees north is called as Tropic of Cancer. So approximately on 21st June, Sun reaches farthest in the Northern Hemisphere. So when we have summer in Northern Hemisphere, Sun appears to move towards the north. And on 21st June, Sun would be overhead at Tropic of Cancer. Means for the timing you can say parallel of 23.5 degrees north. Then from here it would appear to take a turn. And when we have winter in Northern Hemisphere and Australians have summer, Sun would appear to move towards the south of the equator. And approximately on 21st December, Sun would appear to reach farthest possible in the Southern Hemisphere, and that is 23.5 degrees south, and this would be called as Tropic of Capricorn. These 2 days, when Sun is overhead at Tropic of Cancer and Tropic of Capricorn, these are called solstices. It means I'll make you write later, solstice would mean Sun reaching farthest in the given hemisphere. Now 21st June, Sun is overhead at Tropic of Cancer. Since it is our summer time, so we Indians will call it as summer solstice. But for the Australians, the people in Southern Hemisphere, the same day would be winter solstice. And 21st December, Sun would be overhead at Tropic of Capricorn. It would be our winter solstice and Australians' summer solstice. And you will see in this 1 year's journey, there will be 2 occasions when Sun is going to be overhead at the equator. One, 20th March approximately, which would be called as a spring equinox. And second would be about 22nd September, which would be called by we Indians as autumnal equinox. For Australians, it would get reversed, right? So there are 2 equinoxes when the Sun is overhead at the equator, and when it is overhead at Tropic of Cancer or Capricorn, they are called solstices. Equinox, today you will understand within a few minutes of the lecture. Equi means equal, nox means night. So equinox would be the 2 days of the year when all places on my earth would have equal length of the day and night, right? And that is why it is called equinox. So basically you will understand within a few minutes that sun appears to move in this area of the world. And that is why I suggested that overhead is not a good term for 12 noon local time, because sun is overhead only here. Sun will never be overhead in this area of the world. But they also have 12 noon local time. So what is the better term? The highest in the sky rather than overhead position. So at this moment you just tell yourself that since the relationship of earth and sun keeps changing, so it appears to us as if sun is also moving. And what is the apparent movement of the sun? It is between the two tropics. Now you certainly would have a question that, sir, why sun is not going beyond 20.5 degrees north or south? Now this will come from one of the 5 reasons we will discuss later. Since I am not interested in discussing that because it needs to go with sequence. So just to give a hint, you all know from school days that our Earth's axis is tilted. So later we will understand the Earth's axis tilt is the reason that sun appears to go only till Tropic of Cancer and Tropic of Capricorn, that is 20.5 degrees north and south. Okay. Now, with this background elements, let's have little further consolidation through my pens and hand, and then I'll take you to the handouts also. Some pictures would be shown. So please take this as what? Earth's axis. It means you have to visualize a globe. So let us see what is the relationship of my earth and sun on 21st December. And I make some observations. You please confirm that they make sense, and then I'll go further. So on 21st December, earth and sun are so placed. Remember, you have to visualize a globe around it, right? So 21st December approximately, earth and sun are, my left hand is the sun and this is the earth. Now I make some statements. I say, in this relationship, southern hemisphere is leaning towards the sun, and therefore Australians have summer. Our hemisphere is leaning away from the sun, so we have winter. On 21st December, sun appears to be overhead at Tropic of Capricorn. Is okay? That is 20.5 degrees south. And on this day, mind this now, on this day, the farthest reach of the sunlight in the north hemisphere would be up to 66.5 degrees north. So when sun is overhead at Tropic of Capricorn, the sun's farthest reach in the north hemisphere up to 66.5 degrees north, and this would be called as Arctic Circle. Now, so once again, this is the relationship of earth and sun on which date? 21st December. Sun appears to be overhead at Tropic of Capricorn, and farthest reach of the sunlight in north hemisphere is up to Arctic Circle, 66.5, something like this. Is okay? Now imagine I'm holding an apple and knife goes through Arctic Circle, then the center, and apple gets cut into 2 halves. Can I say when the light is cutting the earth like this, mind this now, when the light is cutting the earth in this position, longer proportions of the parallels of the southern hemisphere are under sunlight? Yes, please? It means southern hemisphere people will have longer days, and shorter proportions of their parallels are under darkness. So their nights are shorter, days are longer. Season called summer. Since our hemisphere is leaning away, can I say in this relationship, the shorter proportions of the parallels of the northern hemisphere are under sunlight. Our days are shorter, nights are longer. Is okay? Now, as earth goes for its journey, every day the relationship will keep changing, but will comprehend a cumulative change after 3 months. Approximately after 3 months, from December, January, February, March, on 20th March approximately, because of some 5 reasons, my earth would be placed to the sun like this. I am the sun, earth is like this. So on 20th March, none of the 2 hemispheres would be leaning towards the sun or away. Both are equiplaced. And where does the sun appear to be overhead? Right over the equator. It means 3 months back, sun was over the Tropic of Capricorn, and in the journey from December to March, sun appeared to move from Tropic of Capricorn to equator, and on 20th March, sun has reached over the equator. Earth is placed to the sun like this. So now let's see, circle of illumination, the light of the sun will cut the earth like this. The light will go reach North Pole as well as South Pole. It means in the 3 months from December to March, as the sun was appearing to move towards the equator, this area of the earth kept coming under light. So when the light will pass through the North Pole and South Pole, can I say it is like apple on the table and knife going vertically down? So when the light cuts the earth through the poles, can I say every parallel of my earth would have half length under light and half length under darkness. It means all places of the earth would have equal length of the day and night. And that is why it is called March equinox. And March equinox for us would be spring equinox, and for Australians it would be the autumnal equinox. And how many of you understand that as earth is going from December to March, can I say days have become longer in northern hemisphere? Yes, please. Signal for we Indians that we are approaching summer, and days have become shorter in southern hemisphere. It means Australians get a signal that they are approaching winter. Now after 3 months, as the earth covers 1/4 of the orbit again, on approximately June 21st, sun and earth would be so placed because of 5 reasons we are not discussing today. So see the relationship. Now which hemisphere is towards the sun? North hemisphere. So we have summer and Australians have winter. And on 21st June approximately, sun appears to be over the Tropic of Cancer. And what is the farthest reach of the light in the southern hemisphere? Up to 66.5 degrees south, and that would be called as Antarctic Circle. Means light would only reach up to this line. And since this is Arctic, so we'll name it as Antarctic. Now, let's see how the light cuts my earth now. So when the light will cut the earth like this, the longer proportions of the parallels of northern hemisphere would have the day, right? Longer days would be there and nights would be shorter. Australian or southern hemisphere people will have shorter days and longer nights. Winter is okay. And I hope you have understood, after 3 months, 22nd September would be same as, the relationship would be same as March. Okay. So are you able to appreciate that circle of illumination, being a great circle, is always cutting the earth into 2 halves, but it is doing so differently at different times, and that gives me the variation, the length of a day, and that is what we understand as seasonality. Is okay? Now one more point before I go for consolidation through diagrams. Can I say equator will be the only parallel of my earth which will always get evenly divided, half length under light and half length under darkness. Remember, whenever you have to cut the apple into 2 halves, knife has to pass through the center. So it means equator will have no variation in the length of a day. Throughout the year, equator would have 12 hours of day and 12 hours of night. Okay. Now, before I go to the sketches, do you notice I have covered one more topic along with the great circle? Can I say in this discussion you have understood equator, the 2 tropics, Arctic and Antarctic circles, can be listed as the important parallels of the earth? Yes, please. Now, if you ask me, sir, why are they important to us? Can I say class has indirectly understood for the coming lectures that the parallels which are marked on the board as important, they are important because they help us understanding the distribution of sunlight on the earth's surface. Because you know, we have understood today indirectly that these 2 lines are the farthest limits of the vertical rays of the sun. Sun will never be vertical in this area and this area. It means the areas beyond Tropic of Cancer and Tropic of Capricorn throughout the year would have more inclined rays, and this area of the world would have more higher angled rays all throughout the year. And you know, when the sun's rays come at higher angle, you have more intense heating of the earth's surface, and when rays come inclined, the heating is diffused. So it means we are getting ready for the coming lectures of ecology and geography, that our earth's surface doesn't have uniform distribution of insolation. Did I use the term insolation? No? So write on the margin one term. It would be very popular in our classes. Please write on the margin. This one. What is insolation? Insolation is a short form for three words. Incoming solar radiation. So please write insolation stands for incoming solar radiation. This would be the most popular term in my classes. Now I'll take you to the sketches for the final consolidation of today's discussion. Yes, someone was asking something. Means circle of illumination is a great circle because yes, that is what I'm just listening to me. Our earth is always being cut into two halves, light half and dark half. So the edge of the light half is always a great circle, and that great circle is named as circle of illumination. Now I'm going to take you to the handout, and that handout is still not on the portal because not much is covered. So after a few days we'll put that handout once we have covered a few things from the classes here. And first I'll show you, I'll show you two different handouts. First let me show you that building called Royal Observatory at Greenwich, and then I'll go to the next seasonality element. See, this is that building at Greenwich, which is the Royal Observatory, and in this building, if you visit sometime there, this is that line which is representing Greenwich Meridian, right? And on the map in UK, it is this place, Greenwich. Okay? So this is the line passing through that Greenwich Prime Meridian. And these are the things we have understood in our lecture today through this diagram, okay? Now more of this handout will be used later for time concepts. Let's leave this also here. Now let us revise our lecture of the last 30-40 minutes. So please look at this and tell me, does it make you understand that as Earth goes around the Sun in 1 year's time, relationship of Earth and Sun is changing. This black line is that Earth's axis. Yes, please? Now this is December 21st, December solstice. Sun is so, Earth and Sun are so placed that Sun appears to be over the Tropic of Capricorn. Southern hemisphere is towards the Sun, northern hemisphere is away. And after 3 months, Sun would appear to be over the equator. After 3 months, on June 21st, northern hemisphere is leaning towards the Sun, and it is over the Tropic of Cancer. Again, in September, it is over the equator. So, see, Sun is not moving. It is the Earth which is moving. And because of the changing relationship, it appears to humanity, the people on the Earth, as if Sun is moving. So the Sun's apparent movement is between the two tropics. Is that understood? Yes, please. Now, why this relationship is changing? This I'll teach you in the 16th lecture because of 5 reasons. Okay. Now, one is already told, tilt of the Earth's axis. 2, by common sense you can understand Earth is revolving around the Sun. So revolution of the Earth is also one reason. And at the time when it is revolving, it is also rotating on its axis. So 3 reasons are already understood. Revolution, rotation and tilt of the Earth's axis. The 2 other I do not remember, that I'll do it in the 16th lecture, right? Because that will create some problems if I bring them today. Now, I'll take one of the anniversary dates, and through this I'll cut the Earth. Means on this particular day I'll cut the Earth, and I'll revise whatever we have learned in the last few minutes of the lecture in terms of length of a day. One thing which I have not disclosed in this discussion so far would emerge in this presentation, and this will give us the basis for my 5th or 6th lecture. Means I'm going to show you something today in this discussion after 5 minutes, which will become the basis for some countries going for a practice called DST. Have you heard of daylight saving time? You might have heard of many countries of the world go for changing their watch time for the summer season. If you have friends in Paris, for example, you will find at some time of the year, the time difference between Paris time and Indian Standard Time is 3.5 hours. But sometimes it becomes 4.5 hours. Whereas the time difference between IST and say London's time is 5.5 hours, but sometimes it becomes 4.5 hours for some season, because these French and English people and many other such nationalities, they go for forwarding their watch by 1 hour for summer season of the year. And we Indians don't do that, no? We Indians use one watch for the whole country and the same way for all the 12 months of the year. So we'll be having a topic called daylight saving time, and that would be based on something what I'm going to teach you through this sketch, okay? So let us take June 21st. Now before I cut the earth into two halves by the light of the sun, let us introduce two more terms which I'll be using in the lecture of seasonality. I'll be using two terms, one near side of the earth and the other as far side of the earth. So sun, this part of the earth is near side and this side is far side. Now I'm focusing on this particular day, June 21st. Can I say it is the time of the year when northern hemisphere has summer? So northern hemisphere is summer hemisphere and southern hemisphere is winter hemisphere. Clear? Now I make a statement, please check. I say on June 21st, the farthest reach of the sunlight in the southern hemisphere is up to Antarctic Circle on the near side of the earth. Yes, please? So see, I make a red dot here up to this, no? So once again, on June 21st, the farthest reach of the sun's light in the southern hemisphere is up to Antarctic Circle on which side? Near side of the earth, right? Now let's have one more statement, keep your eyes on the board. I say on June 21st, the farthest reach of the sun's light in the northern hemisphere is up to the Arctic Circle on the far side of the earth. Means since earth is leaning towards the sun, so light is going on the other side also. But how far? Only till this point. Is that okay? It means it is like if earth is my apple, it means the knife is going like this. Is okay? Yes, please? Now, as already understood, whatever may be the day, equator will always have half length under light and half length under darkness. It means no variation in the length of a day. So we do find in books, a book will say, changing length of a day is a manifestation of seasonality. But can I say this statement is not correct for equator? Because at equator there is no variation. But the moment I leave equator, I find that there is a variation in the length of a day. Now what is summer? Days are longer, nights are shorter. So let's check. In June, northern hemisphere is summer hemisphere. So let's see what is the situation here. This is the proportion of the parallel under light. And this is the proportion of the parallel which is under darkness. Is it clearly visible or not? Day is longer than night. Let's go to winter hemisphere. The length of the day is this much and night is longer. Yes, please? So it means you have understood that length of a day is being decided by how the circle of illumination cuts my earth into two halves. Circle of illumination being the great circle always cuts the earth into two halves, but it does so differently at different times. Now comes more interesting point which I have not disclosed so far. And now you keep your eyes on the board and this will give us the basis for our 5th or 6th lectures topic. I say, keep your eyes on the board, I say, as we go higher in summer hemisphere, the days are getting longer. Yes, please? As we go higher in latitudes towards the poles, what is happening? Days are getting longer. It means you need to understand that when you are in India, summer day is longer than the winter day. But if you are in Europe in summer season, their summer day is much longer than their winter day. It means if you are in a city like Paris during your summer vacations, and let's say you are there for the first time, then you will have two surprises immediately. First surprise will come when you sleep in the hotel room in the first night. Very early in the morning, you will be disturbed in your sleep because of too much of sunlight in the room, because you didn't put curtains on the window. And what is the second surprise? Second surprise will come in the evening when you are moving on the roads or the streets of Paris. The watch may show 10 p.m., but the light around you will be so much as if it is 4:30 p.m. of Delhi. So for 1 or 2 days, you might have problems having dinner, because for dinner we Indians wait for darkness, and by the time darkness prevails in a city like Paris or some other high latitude city, the restaurants will be closed. And for 2 or 3 days you struggle with this particular rule of nature, and by the time you understand the game, your trip is over. No, because we Indians go for 4 or 5 days, this becomes a costly trip. No. So by the time you understand the game, that their days are longer in summer and all that, then you have to wait for the next trip. No. So let us see now, if I go higher in latitude, what is happening? This proportion is longer than this proportion. Yes, please. The day has become further longer. Let's go little more further up. The day is longer, night is getting shorter. Is okay? So it means the understanding is that as we go higher in summer hemisphere, means as we go higher in latitudes, summer day is getting longer. It means these countries which are here, they have very early sunrise and they have very late sunset. Okay. So in my 5th or 6th lecture, I'll say that when they found that nature has given us many hours of sunlight, so an idea came in the minds of these people that why should we not use this sun's energy more efficiently so that our other energy sources requirements are reduced. And for this they will have to make a change in their routine, daily routine, and they will do it by forwarding of their watch for the whole summer season by usually 1 hour. And this practice would be called as daylight saving time. Okay. But at this moment this is a topic of 5th or 6th lecture, but you just understand this, that in higher latitude, summer day becomes longer and longer. Early sunrise and late sunset means night is getting shorter. And a few more interesting things will come, means you will have more surprises in the lecture on DST. Now let's see the other story. Keep your eyes on the board and now focus on the winter hemisphere. Can I say, higher we go in the winter hemisphere, in terms of latitude, the days are getting shorter, nights are getting longer. So see, as I go higher in southern hemisphere, the day is getting shorter, night is getting longer. So winter days are getting shorter. Is okay? Now, I repeat, summer days are getting longer in higher latitude, winter days are getting shorter. If I have to sum up both these sentences in one, if I have to sum up both these things in one sentence, can I say, higher we go in latitudes, the seasonal variation, the length of a day keeps increasing. See, what is the seasonal variation, the length of a day at the equator? 0. Throughout the year you have the same length of the day, no? But as you go away from the equator, either towards the north or south, is the variation of the length of a day increasing or not? Yes. Summer days are becoming longer and winter days are becoming shorter. So it means I can sum up in one sentence, the seasonal variation, the length of a day increases towards the poles. Okay. And in particular we'll use the point of summer day for the topic of DST. Now if this is good, I hope you will appreciate this yourself. The same way we can understand December story, and indirectly you have understood also, these are the 2 days of the year when you have all the parallels of the earth being cut evenly. Remember, there are 2 days only when all parallels will get cut evenly, half length under light and half length half length under darkness. So they are called equinoxes. But otherwise, equator is the only parallel where you have even cutting for the whole year. Okay, so these are two equinoxes. One would be called as spring equinox and the other would be called as autumnal equinox. Okay, now let us come back to our main topic. Remember, we started with great circle. Now I would share with you one more point on great circle, and this point is a mathematical property of great circle and will be having application in our life. So we'll take one property from mathematicians and use it as effect for our life in general and classes for the examination purpose. And with that, I'll be over with this presentation, then I'll give you all the notes on whatever I've spoken about. Now what is this last point? See here. If I make my left hand a plane, you all know if I take any 2 points on this plane, the shortest distance would be between these 2 points along a straight line. So on a plane, a straight line gives me shortest distance between two places or 2 points. But you know, today we are not talking about plane surfaces, we are talking about spherical surface of the earth. So if I say there are any 2 points, mind the words carefully, if I say there are any 2 points on the earth surface, means surface of a sphere. If there are any 2 points on the surface of a sphere, say earth or in general globe, and these points are A and B, then mathematicians can prove that the shortest distance between these 2 points on the earth surface, means surface of a sphere, will always be along the arc of the great circle passing through these 2 points. So think of this point, that the shortest distance between any 2 points on the surface of a sphere will always lie along the arc of the great circle which passes through those 2 points. It means if my left hand is a globe and you choose any 2 points, I repeat, for some reason I am emphasizing, you choose any 2 points on the globe surface or on the surface of a ball, then mathematicians can prove that the shortest distance between these 2 points will be always along the arc of the great circle. And this is what you have read in school books. The arcs of the great circle provide the best routes for sailors to sail from one city of the world to another. Means to the extent it is possible, the sailor will always like to go along this great circle route because it will save on time as well as fuel consumption. I don't know for what reason. So every school book only mentions about sailors, but don't think the same rule will be applicable even in civil aviation. And that is why those of you who have gone in international flights, you would have seen that on the screen, the city from where you are taking off is connected with an arc to the city where you have to go, the destination. And today you understand that arc which you have seen on the TV screen, that is the arc of a great circle. So arcs of the great circle provide us the shortest routes. And this is a mathematical property, means mathematicians can prove it, but we are in a geography class, we just need to take it as a property. But if you still want to get convinced about it without mathematical proof, after the class is over, take a ball, mark any 2 points of your choice, then take a thread, and with the help of the thread, join those 2 points in many different ways. And within a few minutes of exercise, you will find the shortest thread joining those 2 points would be when the plane of the thread is passing through the center of the sphere, means it makes the arc of a great circle. Okay. So with this, my presentation is over. So let's write points on great circle. Then we'll write about the important parallels and other things which I've taught about this seasonality. Please write first point. Any plane, Plane, that is passed through the center of a sphere now just hold on for a moment. There's a student Abhishek asking about the why there is so much of light and all that for months together in higher latitude countries. See, I told you that I'm not teaching seasonality today, no? So I can't teach. If you have got a hint, it's good enough. Otherwise, be patient with the coverage. I understand. It means I understand that you have curiosity to know more now. Yes or no? But I stop it by saying, where was this curiosity for last 15 years? Okay. So I'm very happy that you are asking me such questions, but see, I have a limitation that in 2.5 hours I have to deliver today's lecture. Okay. So let it come in sequence. And that is why I mentioned that this would be in my 16th lecture, so that you don't have such questions. Okay. So please focus on what we are doing today. It would be, see, without circle of illumination, I can't teach you seasonality. And so somewhere we have to make a sequence. So please write, I repeat, any plane that is passed through the center of a sphere bisects that sphere and creates a great circle where it intersects the surface of the sphere. Second point, a great circle is the largest circle. A great circle is the largest circle that can be drawn to a sphere, and it represents the circumference of the sphere. Next point, I repeat, a great circle is the largest circle that can be drawn to a sphere, and it represents the circumference of that sphere. Okay. Now write the next point. There are infinite great circles for a given sphere. Now you write, next point, of all the parallels, put a comma, equator alone makes a great circle. Of all the parallels, equator alone makes a great circle. Next point, each meridian makes a semi-great circle. Is that right? Yes. You need to remove the mask. I'm not getting you. See, concept of great circle is for a sphere, right? And for the topic of the day, we can avoid the mountains and other features of the earth's surface. We can take it as a spherical body. So that is what. So you have written each meridian is a semi-great circle. Now you write for the next point, the subtitle, circle of illumination. Under this title you write, sun illuminates one half of the earth at any given moment. Sun illuminates one half of the earth at any given moment. Full stop. Next sentence. Same point. Next sentence. The edge of the sunlit hemisphere. The edge of the sunlit hemisphere. The edge of the sunlit hemisphere. Put a comma. Called the circle of illumination. Called the circle of illumination. Again the comma. Is a great circle. Called the circle of illumination is a great circle that divides the earth into light half and dark half. That divides the earth into light half and dark half. Okay. Now write the last point in this subtopic for great circle. Please write arc of the great circle. Arc of the great circle. Joining any 2 points. Arc of the great circle joining any 2 points on the earth's surface. Joining any 2 points on the earth's surface is always the shortest route. Is always the shortest route between the points. Is always the shortest route between the points. Now see in this sentence, please underline the words any 2 points. By emphasizing this, I want everyone to realize that this statement is good for any 2 points, because some students will not understand this point, that they will think that we can join some particular points only by arcs of the great circle. Whereas you have to understand, by having a ball after the class or some spherical object in your hand, that you may take any 2 points on the surface of a sphere and you can always join them by the arc of the great circle. Okay. Now write the next title. Important parallels. And please make a diagram fast. Show important parallels. 0 degree, equator, Tropic of Cancer, Arctic Circle. Then there are mirror images in the southern hemisphere. Please do it fast, like students would be waiting outside. We have to write some notes also. Now please see here, before we start writing, in this tropic, like in this term, Tropic of Cancer and Tropic of Capricorn, Cancer and Capricorn relate to zodiac signs of the times when this system was developed. So these two terms are meaningless in the present context. So I have nothing to explain about the two terms here. It is like your name, and if I ask you why your name is so, you will say, go and ask my parents, no? So same way, this is what is done in the past. But I need to tell my class why or what is the meaning of the term tropic. So very soon we'll write, see here, the word tropic comes from the Latin word tropicus, which means in Latin turn. So it means it is that parallel from where sun appears to take a turn. That having reached the farthest position, sun appears to take a turn from here, right? Then Arctic is just the name, nothing to explain. Circle, because you know parallels are circles only, and the opposite hemisphere, the same line would be called as Antarctic circle. So please write some observations on this diagram. Please write. The parallels shown in this diagram are important. The parallels shown in this diagram are important as they help us understanding the distribution of insolation on the Earth's surface. As they help us understanding the distribution of insolation on the Earth's surface. Distribution of insolation on the Earth's surface. Next point, please write. The two tropics represent the farthest limits of the sun's apparent movement Similarly, write one more sentence, please write once again the same way. The two tropics represent the farthest limits of the vertical rays of the sun. The two tropics represent the farthest limits of the vertical rays of the sun. The two tropics represent the farthest limits of the vertical rays of the sun. Done? Now you write next the term solstice. Please write the term solstice refers to the sun reaching farthest in the given hemisphere. The term solstice refers to the sun reaching farthest in the given hemisphere. Sun reaching the farthest in the given hemisphere. Then write next the term equinox. The term equinox refers to the 2 days of the year. The term equinox refers to the 2 days of the year when all the places of the earth have equal length of the day and night. The term equinox refers to the 2 days of the year when all the places of the earth have equal length of the day and night. Is okay? Now let's write a few elements or observations for seasonality. So write the title seasonality. Someone wants me to repeat equinox. I said the term equinox refers to the 2 days of the year when all the places of the earth have equal length of the day and night. Now let's write a few observations of seasonality as understood in this lecture. Please write. As earth revolves around the sun, put a comma, right? The relationship between the earth and the sun keeps changing. the relationship between the earth and sun keeps changing. The relationship between the earth and the sun keeps changing. Put a hyphenate. Seasonality is a consequence of this changing relationship. Seasonality is a consequence of this changing relationship. Seasonality is a consequence of this changing relationship. Next point. Seasonality gets manifested by changing length of a day. Seasonality gets manifested by changing length of a day. Seasonality gets manifested by changing length of a day. Next point. Length of a day depends upon the fact. Length of a day depends upon the fact that how circle of illumination cuts the earth into two halves. That how circle of illumination cuts the earth into two halves. I repeat, length of a day depends upon the fact that how circle of illumination cuts the earth into two halves. Next point. Circle of illumination being a great circle, circle of illumination being a great circle, circle of illumination being a great circle, always cuts the earth into two halves, always cuts the earth into two halves, but it does so differently at different times of the year. But it does so differently at different times of the year. But it does so differently at different times of the year. Now write the next point. The seasonal variation in the length of a day increases as we go higher in latitudes under this you write two sub results. Higher the latitudes, longer is the, complete this, longer is the, yes please, summer day. And second result is, higher the latitudes, shorter is the winter day. Shorter is the winter day. Now see, based on whatever you have done today, please revise this at home and then finalize. See, some students have such a approach that they want to have questions again after the class immediately. No. See, it won't serve the purpose. I have done my best in 2.5 hours. Now you need to do something of your own, and then if you have a query, raise it in the next lecture. Class is not over. Just 1 minute. You are not, means lecture is not over with this. Just wait for a minute. Who said this? Who is? No extra comments, okay? It is a teacher who will make always extra comments, not the student. See, you distracted me. Now there is a student asking me, higher in north or south? See, this is what happens. The summer means when you go higher in latitudes, when I say summer day becomes longer, it means that whatever hemisphere, whenever they have summer, higher you go towards the poles, you have longer summer day. Now, in the next lecture, we will be having the beginning with a small topic where we will convert each degree of latitude and longitude into linear distance. Okay, so we'll be converting the angular distances into kilometers for the earth into linear distances. Okay, and then we'll go for rest of the things. Okay, now I'll take leave from online students. Thank you very much. Keep enjoying the process. The results should be great. Same for offline students.